Okay, let's continue to look at our sum and difference identities. In particular, let's look at sign. Notice with both sign, sum, and difference identities. Here you have sine, cosine, and cosine, sine, versus when you have the sum and difference for a cosine, it goes cos, cos, sine, sine. Also notice with sine, the sum, you also have a sum. Plus is plus, minus is minus. Versus with cosine, you have plus, then minus, and then minus, then plus. So these are things to keep in mind as you're working, because now we're going to work backwards a little bit. So if we look at example 2, we have cosine of 87, cosine of 93, minus sine of 87, sine of 93. So because it's cos, cos, and sine, sine, we know it's cosine sum of difference. And because we have the minus there, we know it's the sum of cosine. So we're going to do the cosine of 87 plus 93. So I know that 87 plus 93 is 180. And I know the cosine of 180, which is what? Remember where 180 is, right? It's that point, negative 1, 0, cosine being x, so cosine of 180 is negative 1. So if it's an angle degree in which you know, obviously you will give the ratio. If it's one that you do not know, that is not in any of the families that we talked about, then we'll just leave it as is. So if we look at B, we have sine cos minus cosine sine. So that tells me that is a sine somewhere different. So because of the minus, we know it's going to be the sine of 40 minus 160, which is the sine of negative 120. Right? So now let's think about our identities for a moment that we talked about. We can pull the negative out and just take the sine of 120 degrees. So the sine of 120 degrees is what? It's in the 60-degree family, quadrant 2. So that's what? Come on. Yes. Square root of 3 over 2. And with the negative in front, that's also negative. So there's our answer. So let's pause for a moment and give you a chance to try C and D on your own. So again, we have with C, cos, cos, minus sine, sine. So cosine of 25 plus 15. It's just the cosine of 40 degrees, which is not in any of the families that we know, so we'll just leave it as cosine of 40 degrees. On D, we got sine cos minus cosine. Again, that's going to be a sine of 140 minus 50. So that's the sine of 90 degrees, which we know, because remember 90 degrees, then at that point, 0, 1, so that makes the sine of 90, 1. E, again, we have sine cos and minus sine of 230 minus 30, or just the sine of 200 degrees. Because again, that's not in any other families that we know. Alright, so let's look at example 3. So here, we're going to use sum of difference identities, but we also have to work out triangles. So let's look at example 3a. Give myself a little bit more room. So we have the cosine of s plus t, given that the sine of s is 3/5, the cosine of t is negative 12/13, and both are in quadrant 2. So quadrant 2, we have a negative x and a positive y. So let's look at s first. Okay? So if the sine of s is 3/5, you know that that's 5 and that's 3. So we can do the Pythagorean theorem to find that x value, knowing it has to be negative. So 5 squared is equal to 3 squared plus the x squared that we're looking for. So 25 is equal to 9 plus x squared. X squared is 16. You know x is plus or minus 4. So in this case, it's going to be negative 4. So that tells me also that the cosine of s is equal to negative 4/5. So if we look at t, given again a negative x, a positive y, that's, we call that triangle, a little bit better. Negative x, positive y, and we're talking about t. Knowing the cosine is negative 12/13. So again, Pythagorean theorem, 13 squared is equal to negative 12 squared plus the y squared that we're looking for. So 169 is equal to 144 plus y squared. Y squared is 25. So y is plus or minus 5. Knowing we have a positive y because it's in quadrant 2, that's going to make that positive 5. So the cosine of t is going to be equal to, I'm sorry, the sine of t rather, is the cosine. So the sine of t is going to be 5/13. So now we know the sine and cosine for both s and t. We can find that cosine of s plus t. So that's going to be cosine of s times the cosine of t minus sine of s sine of t. So now you can just fill in based upon what we already found. So our cosine of s, negative 4/5. Our cosine of t is negative 12/13. Minus sine of s, given is 3/5. Our sine of t, we found to be 5/13. Alright, so now keep it going. We got 48 over 13 times 5, 65 minus 15 over 65. So 48 minus 15. So it'll give us 33 over 15. Okay? So we're taking what we know based on the triangles, finding the sine and cosine respectively, and then using sum and difference identities. Okay? So I'm going to give you a moment to try B on your own. Okay, so let's take a look at B. We have our triangles that we worked, knowing that A is in quadrant 2, so a negative x, positive y. B is in quadrant 3, a negative x, and negative y. To find the cosine of A and the sine of B respectively. Okay? So now we'll have a sum of sine. So sine A plus B That's going to be the sine of A cosine B plus cosine A sine B. So now we're just plugging and chugging again. Okay? We got the sine of A given in the problem, 4/5. Cosine of B given in the problem, negative 5/13. Plus cosine of A we found to be negative 3/5. The sine of B, negative 12/13. Now we just multiply those out. And obviously you can use your calculator and math rack if you need to. I'm going to have negative 20 over 65 plus 36 over 65. Negative 20 plus 36 is going to give us 16 over 65. Okay, make sure you review what we have just gone over for both examples 2 or 3 in the additional video for example 1, and we will go through some practice problems later in class.